Hello everybody. Today we are going to do, as Rene said, seismic attribute analysis on OpendTect. We will start with the introduction, with introducing ourselves with this key part of OpendTect by defining several structural or stratigraphic attributes, and then we are going to apply them on a 3D volume and on several horizons. I hope that you will enjoy today's talk. Before we start the major parts of today's presentation, I would like to mention that there are many attributes available for you. Some are free and some are not. But here you see that on the left hand side of this table in the column 1, I have presented some key attributes that are actually for free, and there are some key attributes that require a license. So if you're interested, send us an email for those license and you can get that. Our goal of this webinar is to illustrate and to demonstrate the features of OpendTect attribute set window. That's the first thing from where you're going to start. To cover this, we will have two parts of our discussion. We will start with the introduction to attributes and its major parts, and then we are going to see some live demos and how you're going to launch the attribute set window. That's the window in which you are going to define the seismic attributes. So normally you can define you can launch this window through analysis menu. So you press this one, or you use this small button which is with alpha letter, A letter, with a small calculator in it. When you click this button, it will launch this attribute set window. This is the window in which you are going to select the attributes, and you're going to define your own library, I will say a list of attributes, and you save this attribute as a set or as a group. However, if you don't know anything about an attribute that you're using in OpendTect, you can press this help icon button to get to read the documentation of the selected attribute. So the main theme of attribute definition starts here. I will say here, you on the left hand side you see basic. At this moment it's a group of basic seismic attributes, and I have selected similarity here. When you select an attribute, then you get its parameters. You need to provide the seismic data, which is input data. It can be seismic data, it can be impedance volume, porosity volume, or any volume loaded in OpendTect. You can select the parameters for that, and then you simply define the attribute and add as a new, and then the attribute appears in the list. So it's very simple. Before we go ahead, I will say the toolbars are very important. These are the buttons that you're going to use quite often. For instance, like saving these defined attributes and using them for later purposes. You need to open or retrieve the sets from other servers, and you probably want to evaluate the attribute parameters. It's a very key thing. Or you probably want to cross-plot different attributes. So let's start, and what I'm going to do now, I'm going to present you some demos using OpendTect and a dataset from a Dutch offshore sector, and we will define an attribute in that data, and we will do some live demos in it. So our first demo, just a brief introduction here about what I'm going to do next, is about a simple reflection strength, I will say, or RMS energy. We are going to evaluate its parameters. So our objective is to delineate this bright spot effectively with the right parameter, and to see how to do that in OpendTect. So I'm going to jump to OpendTect for a while to demonstrate this. Okay. Here you see an OpendTect scene. I have several elements loaded in there. I just need to hide some because that does not serve my purpose at this moment. Just a demo. Okay, I hide these things and I only view one inline. That is my primary objective at this moment. Okay. What you see in here is a bright spot, a very bright amplitude anomaly, and you see there is a very clear trough in there. What I want to do, I want to define an amplitude attribute in here that only define this anomaly. And well, how I'm going to do that, first of all I need to launch the attribute set window. As I said earlier during presenting the PowerPoint presentation, I can go through analysis attribute. This will launch the attribute set window. In here what you see is the same thing that I presented in a slide. So here I need to define the basic energy type of attributes. It's an amplitude attribute, and then I need to provide the seismic data. I press select button. I provide dip, steer, mid, and filter. That's the seismic I have, slightly neat and clean. And I can provide the time gate, for example, 12 millisecond, minus 12 millisecond above a sample value, and 12 millisecond down. So it's a trace attribute only on one trace, so it's working sample by sample downwards. So I select the right parameter. I call it energy minus 12 plus 12 second. This moment I don't know its parameters, so I'm going to evaluate that. I select this the newly created attribute. I press evaluate button. So it's this button with several panels in it. So I press this one. It launches the evaluate attribute set window. So I need to hide a few things to just show you things there. So here I need to select the right parameters. I start with a value of minus 12 plus 12. I increase the value according to the sampling rate of this data, which is 4 millisecond, and I create multiple views like number of 5. So after every step it is going to add this increment in this initial value, and it is going to calculate that parameter for the energy. So I select this data and I press calculate. Here you go. So you need to select the right color bar. If you don't like this color bar, you can select the other one. At this moment the bright amplitude is pink to red. So here after this you have 5 views for different time gates for one attribute, which is energy, and you can slide or rotate that. Probably there are 2 or 3 events highlighted at this time gate. I think it's pretty large enough, and if I decrease the window and narrow down the wavelength, and probably 12 or minus 16 plus 16, which is total 32 millisecond window, is fair enough to delineate this bright spot that is pink color. So I press accept. Once this is done, I can change it. You see, you go back to attribute set window, and when you press accept, it updates the time gate. And then I can change this attributes parameter and press add as new. So this is the final attribute that I have decided to describe the bright spot, which is bright anomaly, amplitude anomaly. I press OK, and now what I can do, I can create an output volume for that. How you're going to do that? You're going to do it simply processing seismic, create seismic output and attribute. Once you select this thing, it will open a new window which is called create volume attribute. So here you can provide the attribute that I was evaluating. So it was RMS energy minus 16 plus 16, and I can write this to a disk or in OpendTect survey. And I can also provide volume subselection to target the object only, for example 200 to 300, and it's valid to this cross line, for example 1000 to 12,300, 500. When you are done with these positions, you have actually subselected a sub-volume from a large survey, and you can run it on a single machine or on a multiple machine. So if you have multiple machines connected with your server, then you can run, you can split the job and it will run quickly. However, I don't have at this moment, so I run it on my own machine and proceed. This is going to launch a batch program, a program that is going to run in the background. So while it is running, you minimize it and you can still work with the OpendTect. So this is very useful, very handy. That does not take too much and does not block anything. You can still continue working with OpendTect and you can continue the analysis. So this was my first demo. Before I go to the next demo, I will like to describe it first. So next demos are actually serving two purposes. One is how you're going to analyze effectively the stratigraphic features, and for that first of all I'm going to define some attributes, and similarly how you're going to define structural features. There are also some attributes available in OpendTect. So before we go ahead, I will first define an attribute set for my further demos. So in this way you will learn how you're going to create a list of attributes, and how you're going to save it, and how you're going to apply it on different horizons or volumes. So our focus will be on a shallow horizon, which shows nice channels, stratigraphic features, geomorphologic features I will say, and the deeper horizon which shows nicely extensional faults, normal faults, and we will do some curvature or some other attribute analysis on it. My next demo is to do spectral decomposition on a horizon. So what I'm going to do next in OpendTect is to color blend 3 spectral responses at 3 discrete frequencies, that is spectral decomposition. I'm going to create 3 spectral decomposition attributes. One is at 20 Hz, that is amplitude at 20 Hz, amplitude at 40 Hz, and amplitude at 65 Hz. One is lower frequency for the data. Other is almost median or mean frequency. The upper one is 65 Hz, which is upper frequency. I'm going to blend that, and I'm going to look at the horizon map to see what does it highlight. So let's go back to OpendTect to see how we are going to do this. Okay, so this is the horizon that along which we are going to calculate 3 spectral decomposition attributes. So before I do that, I need to define a library for next demos. So I go to Analysis, Attributes. I relaunch the Attribute Set window. I create my own library here. I press I go to the group, I select all, and on the right hand side I select the attribute from the all list, which I need to find spectral decomposition from the drop down list. Spectral decomposition. Here I am going to use input data, which is seismic data, and I'm going to do FFT type of decomposition, and for that I need to know the target window. I already know this thing, luckily, and I put the time gate here. And the next is output frequency. In output frequency, you are actually getting an output at this frequency and output amplitude at this frequency, which is spectral decomposition. And the steps are the increment in the frequency. So at this moment I have 5, so I can put it to 10, and you see next is 40, 50. This is just to move the slider. So spin box, actually I call this attribute as FFT, spectral decomposition, with a time gate 32 millisecond, and its output frequency is 20 Hz. I write its name and I press add as new, and then it appears in this list. I can change the frequency. Next frequency is almost the mean frequency 40 Hertz. I put a new name, I press add as new, and next is I want to use 65. There you go. Here you go. Sorry, shall use 40 again here. There you go. So I have defined 3 spectral decomposition attributes which are to be used on the horizon that is displayed in the background scene. So next was to create some structural attributes. There are several attributes available in OpendTect, and I will start with the key one, which is similarity, a type of coherency or trace correlation. So here I need to select the same seismic data that I'm using previously. I need to provide an optimum time gate. I provide that, and I can set its parameter, how many traces that I want to use in the neighborhood to be compared. And at this moment I am using 1 versus 1 in each direction. It's done in symmetric sense. So 1 trace next, 1 trace in the inline direction and cross-line direction, and the same is the case for the previous traces. So it is done in a full block with 9 pairs, and I can create a simple different type of similarity, which is full steered, which is using structure oriented dip to compare the traces, or you can do it in a conventional way, which is a conventional coherency type. I will call it conventional similarity, which is non-steered, which is not using structural dip, and I provide its time gate 24 right parameter. This is very important. You need to provide the attribute parameter so that when you're going to use it in future, you should know what parameters it has in there. So that's why for each attribute parameter I'm putting its parameter. And next I'm going to create full steer, which is going to use steering cube detailed. I'll go dip steered similarity with the same parameters. The only difference between these two is one is using steering, the other is not using any steering. And I can create curve dip type of attributes. For example, dip attribute requires a commercial plugin as for dip steered similarity. For that you need a steering cube, and I can calculate polar dip. There are optional attributes which are the components of dip, like in principal direction, inline or cross lines, or apparent dip. That's very interesting. This is a dip measured from a certain azimuth, so that gives a geologic sense. So you can call it apparent dip at 0 azimuth, and you can change these values like 45, and 90. So this azimuth is made from true geographic north. And I can calculate another structural attribute, which is curvature. And for the curvature, there are different type of curvature available in the list. That's called output. And at this moment I need most positive curvature using a detailed dip information. That's coming from steering cube. I call it most positive curvature detailed, and I can similarly calculate other ones, most negative. And similarly there are other that's very nice, I think might be important for some audience, some people who use simple statistics. Volume statistics is a very interesting attribute that simply calculates different type of statistics, like average, variance. If you want to calculate a variance cube, you simply use this one. It works in both sense, vertically and laterally. So, and for example, if you want to calculate average property maps, if you have a property volume like porosity cube, you provide the right statistics 0 to 20, for example, and I calculated it trace per trace. I don't use any trace in the lateral direction. I calculate average porosity for a reservoir, for example. So in this way you can calculate, you have defined a library or a set, and you can save it by pressing this save button, save attribute set. So I call it my Spectral Stratigraphic attributes, and I save it. So once it is saved, then its name should appear here. So I have already defined for this webinar a comprehensive library. It's webinar, and I'm going to demonstrate them in some of them on your horizon, especially curvature, dip, similarity, and those things. Press OK. So let's start with spectral decomposition first. So as I said earlier, that I need 3 spectral responses, and I'm going to blend them. So I need to load a color blended horizon first. How you're going to do that? You right click on horizon and you select load color blended, and you select the right horizon. So in this way it is going to load a horizon with three major semi-transparent attributes along it, and they are by default blank. You need to load the data on it, and the fourth one is alpha channel, which is transparency. So at first I need to load green channel, and a green channel at this moment what I want is a red channel. I'm sorry, red channel is low frequency, and green channel is intermediate frequency, and blue channel is higher frequency. So I need to load 3 attributes. I can do that in 2 ways. First, I can load that on the fly like this. You right click on the red color, which is at the lowermost attribute for the horizon, and you select this one. It's going to run a batch process on the fly, and then you need to wait till it is finished. However, you can do that in another way around. You abort this process, you go to processing, you go to grid output, you select grid. In this way you are going to run the same process that I was running on the fly, but in a batch program that is in the background, and I can still work with OpenTect. I think that's more suggested way of doing this thing. I select grid, and here it will ask quantity to output. I can select the same attribute. I actually need 3 attributes, so I will run this process 3 times. So I select the first one, which is 20 Hz, spectral decomposition at 20 Hz, and I run it on the horizon. By default, it is going to use the attribute name, the name that I have provided in the attribute set window. And I have provided a surface here. I simply press proceed. So here you go. It's going to run the batch program in the background. Till it is finished, I can run another processing grid. So I do it for the next one, and in this way I continue for the third one also. So I have already pre-calculated these things, and I can retrieve them from the surface data. If you right click on the attribute, you go to select attribute, and there you select surface data. You see currently I have 23 grids stored along this horizon. So I try to find the same thing. I select that attribute, which was 20 Hz spectral decomposition, as a red channel. So here you go. It loads that data as a red channel, and I load next surface data, which is stored grid, attribute grid, which is 40 Hz as green, and the blue one is higher frequency, 65 Hertz. Here you go. So here you go. So OpendTect has given you opportunity to color blend things very also easily. You see how nicely I have blended 3 spectral responses and how do they look like. So what does it show? It shows me a response like if red amplitude at 20 Hertz is almost equal with 65 Hertz, then they are semi-transparent, so they are going to blend together with the magenta color. And similarly, if the lower frequency is equal to intermediate frequency, which is 40 Hertz, you're going to get a yellow color. So on this map, we are getting green channel here, which is a green color dominant response for these channels. These are deep marine channels, and these are actually highlighting the levees. And on the other side, I see some features which are almost parallel to each other, but they are perpendicular to the channel, and the paleocoastal line is almost parallel to these linear patterns, and they are actually sand waves or sediment waves. So you see, in this way, I know that how much is the frequency there and how thick they are. So these sand waves are pretty thin enough, and here they are slightly thick, and they have dominant frequency response. Within the channel, I have thin sediments in the down dip direction. So in here we have a chance of more turbidite sediments. They are also mixing. Their response is not much resolved, so they are giving red plus blue color mix up with it as a purplish or magenta color. So a very interesting attribute, very useful, and if you know the velocity, you can convert these frequency responses into I would say meters, and then you can also generate several thicknesses maps, and you can do prediction for as well. Yeah. That's the first, I will say, second demo. Our next demo is to focus on mainly, I will say, structural features and some stratigraphic features hidden within the structural features. For that, we are going to calculate, we are going to apply 3 more attributes on a horizon, and those are actually depth, curvature, and similarity. And then we'll see what does they highlight and what is the significance of that on that horizon. So I press escape and I go back to OpenTect. So the horizon that I was highlighting this in the slide was this. You see nice displacements along this horizon, and if you look at this section through it, and you see there are nice faults and the nice extensional faults. So what I want to do, I want to calculate in the same way some attributes along this grid, and I'm going to run those processes in the background. First of all, I need to view it. I need to create a map view. So to do that, you go to OpendTect toolbar, you select View North Sea option, and then you view it from the true north, but from the top, and then you can switch the cameras to orthographic, that is 3 sides perpendicular to each other, and then you can zoom it in. Here you go. And I can run some attributes along this horizon. I select grid, quantity to output, like dip steer, like conventional similarity, which is normal similarity minus 32 plus 32, and I'm going to run this on a horizon. Base tertiary, I press proceed. Here you go. So this is running that attribute. I can do processing, same thing for another attribute like dip steered similarity. And I press proceed. By default, I'm selecting the same horizon that you're looking at this screen, sorry. So, and I can do the same thing for the rest attributes like curvature, dip, or apparent dips. I have done this already, and I have several attributes saved as a surface data along this grid, and I can check that through survey menu, manage, and horizons. So if you launch horizon 3D horizon management window, you select the horizon that I was looking at. It's base tertiary small, so I select this one, and you see I have several attributes grids stored as a surface data for this horizon. So let's see that base tertiary small. I'm going to load conventional similarity on it. I right click, I added a new attribute, I right click on it, I select the attribute and go to surface data, and in here I select non-steered conventional similarity. Here you go. If you select this one, you can change its color. By default it's using a default color. I can change that, like currency I have, and I have prepared that for me. And I can compare this with dip steered similarity. I added a blank attribute again. I'll reload the surface data, the stored surface data, and this time I select dip steered similarity. I select this one and I give it the same color so that I can compare. Here we go. And I need to clip the data in the same way. The color ranges should almost be the same, 0.95 to 0.7. I select the other attribute and put the same color range. Here you go. I zoom it in and look where I have complexity. So here I see some structural features, and within these structural features you have some stratigraphic features. They are slightly hidden there, and if you toggle dip steered similarity on and you compare this thing with the previous map, if you compare this thing with the previous map, just this one, you see there is a huge difference. So dip steered similarity is a similarity which is structurally oriented, and that's why you see a nice image there, that is the trace versus trace. They are correlated equally and they are correlated in a structural sense. So that's why you see some nice structural features there or stratigraphic features there. However, in case of non-steered, that is conventional similarity or coherency, you're not going to see it clearly. So if you're going to use dip steered seismic attributes, I think you're going to get much structure and stratigraphic sense, and you will reveal more. And this is not it. There are some other attributes that I want to see on the same horizon, like dip. Like polar dip. Here you go. I zoom it out and see the entire horizon. And I give it nice color. Here you go. So if you look at the dip map on this horizon, you see that there are some structural features and stratigraphic features, and looking at them at the same time. However, you can rotate this way. I will say the attribute by creating apparent dips. The dips are measured at a certain azimuth, like looking from north, which is 0 degree from north, and you press OK, and you give it the same color. Here you go. And if you compare this thing with this one, you see a lot of difference in there. And I can look for another apparent dip, which is east-west surface data, 90 degree. Yeah, here you go. You see one apparent dip measured east-west is highlighting and the faults, and however the other one is highlighting the faults which has other trends. And there is a nice stratigraphic feature hidden in here, slight sudden channel, and you don't see in there. So if you compare apparent dip with the dip from north, that is this one, with the dip east-west, you see that the channel is not highlighted in east-west direction, but it is mainly highlighted perpendicular to it, which is north. Contrary to this, I have, let me remove these things, and I also have curvature grids loaded on this data or on this horizon. I can show that. I go to detail curvature map, positive one, and I can also load most negative curvature detailed, which uses a small window or wavelength. And I put the same color. There is a default curvature color bar, should be available for you, and I select curvature here. I can flip the color bar to give them the same visualization, and I can toggle them on, off and on. You see most negative curvature shows more depressions or more downthrown sides of a forward block, and if you toggle it off, then you see a most positive curvature which shows positive features, that is anticline or upthrown sides of a forward. And to visualize that, I put a cross section through it so that you can understand it, and I zoom it in, and currently what you are looking at is a most positive curvature, like here, upthrown side of a forward block. And if I toggle most negative curvature, you see downthrown side of the forward block or synclinal shapes. So a very nice attribute for structural analysis, I will say. You can do exploration and production, and you can delineate, I will say, exploration and production phases using this attribute. It's very strong, and it's using our dip steering plugin. And however, the difference is that probably I will say, if you compare this thing with the similarity or coherency or depth maps, then you might have difficulty in visualizing the stratigraphic features, but it's very good for structural analysis. This is it for this demo, and go next. So we have done 3 interesting demo. Next one is, I would say, very simple, very conventional, but the purpose of showing the next demo is that how you're going to integrate 2 attributes, like if you have previously I have stored a surface data along horizon, like horizon grid attribute, and how I'm going to use that. And I can create a horizon attribute in OpendTect, and I use mathematics to convert it into different attributes or create new attributes. But in here, our focus is simply create an isopack in OpendTect, which is in true travel time, use a constant velocity, and convert it into depths. So for this one, I have a horizon grid, an attribute along horizon, and I'm going to use a horizon attribute together with mathematics to convert it into depth. So let's do that. Here you go. So let's go back to our previous horizon. Display all on sections. I display the inline. So, okay, here you go. So on this inline, you see there are 2 horizons, yellow and red. What I want to do, I want to calculate an isochrone map or isopack map between these 2, and I can do that simply by right-clicking on a horizon. So let me remove the color blended horizon. So at this moment, the red horizon is demo 1 MFS4, and you right click on it and you calculate isopac map 2. So if you click on this option, it will launch an isopac creation window. In create isopac map, it will ask you to calculate 2. Here you need to provide a second horizon. Second horizon is yellow one. I select that horizon and I call it isopac grid in seconds. Yeah. And I press OK. It calculates the isopac grid on the fly on the selected horizon. At this moment it is the red one. Here you go. I can display that in full again by right clicking on it. Here you go. So what you see in here is an isopac grid ready for you. You can change its color. There you go. And as it is done on the fly, I need to save this one. I can save this grid by simply right clicking on it, save attribute. So it will be saved as a surface data for this horizon. Press OK. So that's it. And the next step is to launch attribute set window to convert it into depth, because currently it is in seconds. I launch the attribute set window through analysis. Once that window is launched, you select all as a group, and here you need to find horizon attribute first. You need to provide any seismic data that is complete along the horizon geometry. It's essential. I think you can use the original data along which the horizon was interpreted if you have, so that the data is extracted along each trace, seismic trace. And here you need to provide the horizon. In that case, I had demo 1. And you can either export, either can create the z values, which are millisecond, or you can use the surface data as an output. At this moment I need surface data. I have isopac map that I created, and I need to provide a name, isopac S4 to FS4. Isopac map from this horizon to this horizon, and its units are seconds. I add as new in the list. There you go, it appears, and I can go to mathematics attribute, and in here I need to write a simple equation, S is equal to VT. So I have time, so I write isopac, it's 2 at time, so I need to divide it by 2. I put small brackets around it, and I multiply it with a constant velocity like 2500. If you have previously loaded a velocity volume, you can provide another variable like velocity there, and if you press set, it will ask for the velocity, but currently I don't have that, so I write 2500 only. So here if you select press set, so I need to provide isopac grid, so variable I will say. So I select and I go to attributes radio button, I select isopac map from between 2 horizon in seconds. So I selected the right one, and in here I call it with the same name but with different units. So you press that. So in this way we have used 2 new attributes, which is one is horizon, the other is mathematics. We wrote a simple equation there, and now we are almost done. So we simply need to calculate the isopac map MF as for in meters on the horizon that we were looking at previously. Press OK, and I add as new, and I run this on the fly. Here you go. So if you press this one, it's going to run a batch program in the on the fly. I already have this. I go there. So I retrieve this previously saved one. Here you go. I put the same color so that I can compare. Here you go. So you see I have sorry, converted the isopath map in second from seconds to a meter. This is it for this demo. I go to next one. There are some miscellaneous, I will say, workflows. Some have already been presented, like pre-stack attribute in your previous webinar, and the other are might be interesting for you is additional, I think, for visualization purposes. And the final is how you're going to calculate volume on the disk, attribute volume. So in next a small demo, less than a minute, I will say, is how you're going to create pre-stack attribute. It is available there. There was a previous webinar on it which explained it comprehensively, and I will simply show you how you're going to do this as a part of this webinar. I go to another survey that has pre-stack data in it. So I'm in OpendTect. So it shows a seismic data, which is along this. I have horizon, objective horizon, and on it close to a well, where I have here, and I have a pre-stack data also in there. So I can use this pre-stack data. I can load it for free in OpenTect, and I can create free pre-stack attributes. So I have 3D data, so I go to Attribute 3D window. If you are working in a survey that has 2D and 3D type, and in the all group you need to find pre-stack attribute. Previously we were loading post-stack data, but in OpenTect the pre-stack data is called input data store or data store. You need to provide that. I have that one. I call it L30 pre-stack, and I can calculate different type of approximation like intercept for this pre-stack data, or like gradient. Currently this is the simplest, most least square output available for pre-stack data in OpenTect, and you can use mathematics together with this to create more attribute like product, and for I variable I provide intercept as an input, and for G I provide gradient as an input. Call it product sum and fruit factor. I can write those equations simply in here. The purpose was just that how you're going to use 2 or 3 attribute using one attribute as an input of previous one. So, and you can do cross plotting, and you can calculate these attribute on the fly on a section, and that's it. The next a quick demo. I will say I think it's very important. It's very good for visualization purposes. It's directional lighting. It's also part of open source scheme, and you can use that quickly by pressing this icon that you can find in OpenTect toolbar. So I'm going to do to show you how you are going to adjust some parameters for that, so that you can illuminate part of a horizon to focus on it and to explain it. For that I go back to OpenTect. I'll launch OpenTect window. I launch the right horizon. And this is the horizon that you're looking at. And I put single color there. You know, if you're not interested in this color, I can change color by right clicking on its properties. and for example red, deep red. That's okay. So here you see that there is a light coming from top. I can rotate that. So in this perspective, you see there is a light shading the features from the top always. That's the artificial camera available all the time in the scene. So you can put a directional light in this scene by pressing this button, set directional light. Once you have done that, so then you see that at the bottom, ambient light intensity. This is the light intensity that you can reduce or increase, because 90 degrees up from top, in this perspective I can reduce that one. You see as you decrease it, it's become more darker. You put at right angle for this view, and then you can change this knob by rotating the azimuth. So once you change this, you highlight the features very nicely. You see there was a nice channel running in here, and if I go to the opposite side, like in here, there were faults, but they're not appearing there, so I can put a nice azimuth there to illuminate these faults. My last demo is very short and very small, might be important for you. It's how to create attribute volumes. In OpendTect, we have two types of store data sets, I will say, as a volume, either as a single component or as a multi-component. That is the volume that has 2 or 3 values in it, and they can be loaded on the fly. For example, steering cube. Steering cube has normally 2 components stored as a data store, like inline and crossline. And similarly, for example, spectral decomposition is an attribute that can also have several outputs, and we store them as a group in one volume. How you're going to do that? Simply go to OpendTect, and there you go to processing, seismic, create seismic output. I select this option, and quantity to output. At this moment, I'm going to select spectral decomposition so that we will see the multi-component outputs. You select this one, you press OK, and simply you can run it on a section. To do things quickly, I'm going to run it on one section only, so that I can demonstrate that one. Press OK, proceed, and once you proceed, for such attributes you're going to get its components. So quantity to output, I can select the desired outputs, like I'm going to put deciles here, 20, 30, 40, 50, 60. And these are the 5 outputs that are going to be calculated for one volume. So I press proceed. Okay. It's going to run some process in the background for you. You will need to wait for them till they are finished. For example, here it says finish batch processing. Once it says this message, so you are done, that processing is finished, you close those windows, and in this way you have actually the output. Okay, so now I load the same stored data, the same volume, spectral decomposition on this section. When you load that one, it's going to pop up a component dialog box. So you can select all of these components in one go, and you press OK. It is going to load those volumes on this section only. So you have actually one attribute, but it is showing 5 or 6 attributes at the same time. And you go back to the scene and you go to interact mode and you use page up or page down keys to see the different views. On the bottom of OpendTect window, you're going to get its information. At this moment, you see I see spectral decomposition at 50 Hertz, frequency is equal to 50 Hertz. So I can change these views and I can view things in a movie style way. So that's the benefit of doing this thing. So you have multi-component displayed and very nice, very important. The last thing I would like to mention is about the dataset that I was using. It's downloadable from the website. You go to opendetect.org, go to share seismic data, and you download it as a torrent. So you can use the same data for your own purpose. It's free, and you can test OpendTect. Thank you. I will say thank you for your patience, and I would like to invite Renee to start talking if she has any question.
Well, thank you very much, Farrukh. We've been having a few questions as we go along,
Okay.
But people have been very pleased with the presentation, and I think it's been very good, very useful, covering a lot of information and a lot of features that people will use on a daily basis. So thank you very much for sharing this with us today.
Okay, thank you.
Now I have had one question, actually two questions regarding the same idea. I think they're just wanting a little bit more information regarding how you go about picking your time gate whenever you're looking at the spectral decomposition, and you limit your time gate to a little bit above the horizon and a lot below. So if you can explain why you're doing this and how you go about picking the optimal time gate.
Thank you. Before I go ahead, there is a very nice presentation available on our website, and it explains, I will say, everything that you are asking. You go to support, and in there you go to how to, and here you are going to find a presentation. It's called strata slicing, and you can download this PowerPoint. It explains, oh no, not the strata slicing, I'm sorry for that. It's called color stacking, and it uses RGB blending in OpenData. It explains step by step how you're going to select time window, how you're going to decide frequency for a volume or for a horizon. And to do things quickly, I can show you on my screen. Here you go. And if you display the horizon on sections, you know that where your bed boundary is roughly for the data set, and you focus on a time gate that is relative always. So -8 is to compensate because the horizon is not actually snapped to an event, and so I use -8 slightly above because sometimes peak was relatively above horizon, and I use 32 milliseconds to describe these send waves mainly and channels. I hope this answers the question.
Yes, I believe that has been answering. Additionally, I guess we can also describe, yes, we have replies that yes, that's good, thank you. We can also describe that there is an exercise in the training manual that goes through this exact process using the same data set, so it can describe in details.
Yes, you can go to OpenDetect training link, and in there's an exercise self-study training for the same data set that I'm using currently in this webinar. So you click this one, so you're going to get you can download the training manual. In there it's a very detailed exercise. You can follow that one also.
Okay, and we have had another question come in asking a good question. Is it possible to apply spectral decomposition on a 2D seismic line?
I think yes, if Helen is there, maybe she can answer. I have tried it, it works.
Yes, it definitely is possible to use spectral decomposition on 2D lines as well.
Yes.
Okay, well, we've had many thank yous come through already, so I'd like to go ahead and say thank you once again to Farrukh. Okay, and actually I have another question coming in now. Now they're asking if we can do the blended color view on a 2D line as well.
That's a good question. I don't know.
I know it is
honestly.
possible on inlines, crosslines, 2D lines. That's something.
I don't think so that we have implemented that. If you know the email address of that person, maybe you can contact him later on, or her. But at this moment, I have no idea because I never tried it on a 2D line. And I will say not really.
So do we have any loaded in that data set we could check?
Yeah,
but,
but it's no, it's not available for
yes.
2D. No.
Now, we do have another question coming in that's saying if you could explain the advantage or the different cases where you would use a fast Fourier transform versus a continuous wavelet transform for the spectral decomposition.
That's a nice question. There is a nice article on it where it's written by Castagna. He's the guy who worked a lot on it, and he explains the comparison between different type of spectral decomposition, and they say that short window is more preferable FFT based, and continuous wavelet transformation is wavelet based, and then you are dependent on wavelet, and the FFT is actually you are strict to a window. So if you are using large window, then you have a different amplitude spectrum. If you are using narrow window, then you're undersampling the data, so you have a narrow window. So that's why FFT has some limitation, and on the other side, wavelet also has limitation. But ideally to highlight the DHIs, it's FFT which is going to be work better than CWT.
Okay, and we have somebody who would like to ask a question aloud, so I'm going to go ahead and unmute them.
Yes.
Asher, you're unmuted now.
Yeah, thanks. Hey Farrukh, you did a nice presentation. It's very informative. I did gain a lot of knowledge from it. And I want to mention one thing, that I am just new to this software. Even I don't know, I don't know, and I don't have an idea to load the data. But I have few questions, like all these features which need the license are also available for the academic license?
Yes. OpendTect has two parts, I will say. For universities, they can access commercial plugins also.
Yeah. Okay.
Yes.
My second question is, you are mentioning here is the square root energy, which is you mentioned RMS.
Yes.
Yeah. How do you select that square energy in this software?
There are several options for an attribute, so they are actually its parameters. So they are already available for you. So you have like square root of energy, natural log of university, and energy, simple energy. It's envelope, peak to trough distance, and it's the amplitude within that distance. So this is almost square root of energy is the reflection strength. So it's available as an output. If you see my screen.
Okay, I can see your screen well. Thank you.
Yep.
Okay, thank you, Asher. And we have another person ready to ask a question. Okay, you're unmuted now.
Okay, are you listening me?
Yes.
Okay, thank you. It was very nice presentation. But regarding to the spectral composition, I would like to ask the question to Rani Borek. It's a little bit technical, not to the application related. I mean, as you just explained why we are using the FFT and CWT. Okay, if I admit that, for the CWT, which wavelet do you have in that software? And other thing is that if we are just concerned to the frequency and okay, we have the better solution, we don't use the short window FFT, so why we not go to the curve-led domain or in the atom-led domain? These are the other techniques that we use a lot in the data processing.
I think, as I said earlier, you can go to that article. It's written by Kestagna. It's called Comparison. Its title is Comparison between different types of spectral decomposition. I think that explains your questions a lot, and it's I think it's very good to read that and apply that on different data sets. I just put a bottom line there simply that both have limitations. One is wavelet dependent, and wavelet also has a time window, so you are actually stretching the bandwidth within by using wavelet decomposition. It works better if you have a very thick reservoir, but if you have a thin reservoir, then it's probably not going to work, like less than 40 milliseconds.
Okay. So second thing is that, okay, it's not the technical question about that. I do own a Mac Apple, and I am a university student, but there are certain modules that are not available for the Mac. So why these are not released? Is there any chance to release soon, or I have to constrain to use it on the?
I have no idea. Probably if Helen, if you are listening to, can you answer to this question, please?
I am listening, but I'm afraid I cannot answer this question.
Because Macintosh, we don't really work directly, and we had a colleague who worked on it, but there are not many users of Mac.
I think that at some point, I hope I don't say anything wrong, but I think that at some point we just decided to not to do all the releases on Macintosh anymore. So yeah, but
so I am disappointed at that point.
Okay.
Okay.
Well, we can always have somebody get back to you. But we do have a programmer who programs exclusively in Mac. So if you can just send me your email through the questions pane, I'll make sure that I put you in touch with him.
Okay. Well, I just have one last thing, because I bought your book, Neural Network, for the last 2 years, and I tried to install it on the Mac, okay, but it's giving some bizarre error, and I don't understand that and why it's not working. Because your module for neural networking it's available for the Mac, surely, because on this DVD it is available, so I don't understand what is the problem over that.
Yes, I'm not sure either. Okay, I do have your email now, so I will put that. I'm not sure what that problem would be, so we will connect you with the proper programmer.
Okay, thank you very much.
You're welcome.
Thank you.
Let's see, I do have another question that came through asking about what particular information we can get from the dip steering attribute.
Dip steering attributes?
Mm-hmm.
That's a good question. Currently we have implemented like a dip and curvature attributes coming from steering cube directly. So for that you just need to provide steering data, and optionally you can calculate dip components like inline and crossline dip, and you can use mathematics to create more attributes. But currently you have these two attributes mainly coming directly from steering cube. Otherwise you have option like simple statistics, but they are dip steered. We take benefit of volume statistics by creating a post-up filter. It's dip steered median filter, which is structurally oriented filter, and for that you can use steering cube also. And we also do a lot of post-track filtering to enhance faults and those things. I think the best suggestion for this questioner will be to join our discontinuity attribute webinar, which is upcoming in next month.
Okay, actually in 2 months. Yes.
In upcoming months. Well.
Okay, that appeared to be useful for the asker, so very good. Oh, here we have another question. Can attributes be applied to the pre-stack gathers as well in the same way?
I will say yes, why not? Because we load it's not actually direct. So we load the pre-stack data, the gathers as a pre-stack data store, and we calculate first of all the statistics attribute, and you can calculate median and average on it, and then you can use this attribute set further on. Does this answer the question?
He says okay, so I guess so. Okay, well, I'll wait another minute, see if we have some. Oh, just saying, very valuable webinar. They have to go now, but thank you very much. So,
okay.
So very good. I'll wait another minute to see if we have some more questions come through, but in the meantime, I'll go ahead and make a few announcements. We made some announcements at the beginning. Two of them would be, the first one is training. There will be training offered in the Houston offices directly before the AAPG. So if you're traveling to Houston for the AAPG in April this year, you can come a day early and come get some training, or a few days early and get some advanced training. Additionally, they're also going to be offering public training in the Enschede office at the end of this month. So if you're interested in either of those, then please just send us an email, chat, and let us know if you would like to be included in those. And additionally, next month's webinar is going to be where we're showing a lot of the new features that are going to be available in our brand new plugin, the Horizon Cube, which allows you to create hundreds of horizons automatically you can use your dip steering to calculate horizons as your bounding horizons. It's a phenomenal piece of a plugin, and so we're going to be very excited to introduce this to everybody, and we're actually going to be introducing it 2 different times. We'll be doing the webinar at our traditional time, which is 9 a.m. Houston time. Additionally, we will be doing it at noon Beijing time for all the people on the opposite side of the world who are normally sleeping during this webinar and have to watch it recorded. So we'd like to make sure that everybody knows about this, since we'll be making a double effort for this. So please tell all your friends on the other side of the world, have them join us. Hawaii, I know you're sleeping too, so hopefully you'll be able to join us this time next month for the Horizon Cube. So please do join us and tell your friends. And I have had a few questions actually come in the meantime, so let me go ahead and start reading these off. First of all, can I select a single offset to see a section or a time slice from pre-stack data? Hello?
Sorry,
Farrukh,
I was muted.
sorry, you muted.
I answered, but I was muted.
Oh, yeah.
Sorry, slightly funny. Yes, you can provide a manual offset range on an offset value there.
Okay, very good. I've also had somebody ask if there's cost associated with the training. Yes, there is cost associated with the training. If you can please let me know what you're interested in, if you're interested in the Houston training or the Enschede training. The Enschede training is actually a 3-day training, which is a full course. In Houston, we do introduction training, which is a 1-day training, and we also will add in extra days if you're interested in that and if other people are doing that as well. So the training prices do vary with these two because they are 2 different approaches. All right, well, if we have no more questions coming through, then I would like to thank our presenter, who I think did a fabulous job today. Everybody seems to be very, very pleased with it, and we've all learned quite a bit. So if you have any more questions, send them along. We can always answer your questions later on. We hope you enjoyed this today, and we look forward to chatting with everybody next month. So have a great day.